Today, we are really fortunate to have Peter Breslin, who started studying cacti in habitat more than 30 years ago, and he decided to get his PhD in cactus evolution and biogeography at 52. He finished his PhD at 58 at Arizona State University. He's published widely on topics of cactus evolution and ecology, including being one of the authors of the Field Guide to Cacti and Succulents of Arizona, published by the Tucson Cactus and Succulent Society. He is currently conducting the 6th installment since 1964 of the long-term saguaro census on Tumamoc Hill in Tucson, Arizona, as a postdoctorate research fellow at the University of Arizona. And I'm just going to turn it on over to him and let him tell you more about it. So Peter, welcome, and thank you so much for taking time from your work to share with all of us. So good to see you.
Yeah, thank you, Max. Thanks for having me. And hello, everybody. I'm a little scruffy because because I've been out in the field actually collecting saguaro data since 7 o'clock this morning, and we are still in the field. And I'm actually able to do the Zoom and do the presentation with you here because of kind of a high-powered tech jetpack thing that has me connected to Wi-Fi, and I'm actually sitting in the shade of a saguaro at the moment here. Let me see if I can show you. You probably could see the saguaro. I don't know, maybe too much sun, but behind me. See behind me is the a bunch of saguaros you probably see. This is the west. This is a west-facing plot, saguaro plot on Tumamoc Hill in Tucson. I don't know if you're familiar with Tumamoc Hill or not, but it's a very popular natural feature. It's actually within the city of Tucson, and a lot of people walk Tumamoc Hill every day and just enjoy, the beautiful Sonoran upland desert and the saguaros and the whole scene. It's a very popular spot. So it's an interesting place to be doing field work and to be doing research because it's very urban. It's an interesting contrast between this survey site and the city of Tucson surrounding the whole hill. The hill itself has been part of human culture for 4,000 years. There's all kinds of archaeological features all over the hill, trincheras and walls and rock art and agave rock piles and all kinds of crazy stuff. So it's a cool place to be working, and I'm really grateful to be doing research and researching saguaros. I'm going to share my screen and get to the PowerPoint. And yes, please do put any questions you have in the chat. And as promised by the promotional materials for today, the topic, as soon as I can get the slideshow up here, which should happen any minute. That's not it. Hang on. Well, the problem with Zoom is the toolbar for Zoom covers part of the screen. Here, I got it.
There you go.
And then I'll expand again. Okay. Sweet.
Perfect.
Perfecto. See, I don't need an IT guy. I figured it out. Anyway, so yeah, the main thing we want to talk about today is how old is that saguaro? It's a topic of great fascination, and it's been fascinating to lay people, scientists, naturalists, anybody who starts to get familiar with the Sonoran Desert, and they start to encounter these saguaros. It's always a big question, and I think in a lot of the news media, you may have seen recently, for example, one saguaro that was estimated as being 200 years old in, I believe it was Marana, sort of an iconic saguaro that's always on Instagram, and it had all these pictures. And the monsoons, came through and it toppled and expired. But the estimate was that it was probably about 200 years old. And so people become very, fascinated by this. So at the Desert Lab on Tumamoc Hill, which is an asset of the University of Arizona, we actually have 114 years of population data for the saguaro population on the hill. And it's great to be part of adding to that long-term data set. So just a little bit of background on saguaros. Some of you might be super familiar with a lot of this, and others maybe not so much. So I figured I would just give some background for the saguaro itself as a plant, as an organism. It's in the order Caryophyllales, and of course in the cactus family, Cactaceae. The entire natural distribution is pretty much within the Sonoran Desert. There are some populations that are kind of, on the fringes. And the life expectancy, and really that's kind of a funny one, but the life expectancy, once firmly established, let's put it that way, is about 150 to 200 years. So we're looking at, based on the human scale, a pretty long-lived organism. I mean, some of them are, really old, and we'll get to that a little bit later. Scientists have found a way to strongly correlate the age of a saguaro to the height of the main stem. And so when we get to the question, how old is that saguaro? That's one of the key ways that researchers have been able to correlate, features of the plant to its age, is by simply using the height of the main stem. So we'll get back to that later. Saguaros have been important to human beings for thousands of years. And one of the other interesting things about the saguaro from an evolutionary standpoint is in our part of the distribution of the saguaro, north of basically Sonora, the state in Mexico, anything north of that into the United States kind of areas, that's only about 10,500 years that the saguaros have been this far north. And that, 10,500 years is a long time to, wait like at the DMV or whatever. But, in terms of evolution, in terms of the way life works, 10,500 years is really nothing. And if you think of a generation of saguaros being 200 years, that's only about 50, a little more than 50 generations, which is really pretty amazing to think about. So it's considered a keystone species that really structures up the ecology of its whole environment, provides a lot of ecosystem services, and it might be vulnerable to both climate change and increased fire risk, especially with Buffelgrass, which I'll talk about later. The range of the saguaro on this funny little map that has all these little icons of saguaros all over it is pretty well illustrated on this thing. This guy, Paul Marocha down here, he does some really great graphics, and I'm using this with his permission, but you can see that the range of the saguaro here around Guaymas, south to Navajoa in this Mexican state of Sonora, and then just barely into Sinaloa. That's outside of the boundaries of the Sonoran. But and then there's some saguaros that are on the edge of the Sonoran and Mojave, kind of the transition. But the main part of the range is all up in here. And you notice that Phoenix and Tucson both are sort of near the fringes of the range of the saguaro. So that's interesting to keep in mind also. And then for some reason, that's a real mystery at this point for science anyway, is that the saguaro seems to have never distributed over to the Baja California Peninsula. And it could be this dry barrier here, the Gran Desierto and the eastern Mojave Desert, or the Colorado subdivision, actually, of the Sonoran, that is just too dry, especially in the winters, for saguaros to establish. So that might have kept them from migrating down the peninsula, and then why they have not crossed the Gulf is a funny one, because one of the main dispersers for saguaros is birds, and you would think, a lot of other plants have crossed the Gulf, but as far as we know, saguaros never have. So, yeah, the saguaro is a fascinating organism. I mean, you're probably familiar with some of it, some of the strategies and adaptations that make it possible for the saguaro to survive, in our environment. This saguaro, by the way, the guy on the left there in the slide, is at my apartment complex in Tucson, and I've given him the name of Frank, good old Frank the saguaro. You'll see a lot of urban saguaros if you check out urban interface kind of desert urban saguaros or landscape saguaros. They're pretty beat up. A lot of them are they have a lot of bird nests in them. They have a lot of damage. They're not always doing all that great, even with supplementary water sometimes. And Dr. Tanya Hernandez at the Desert Botanic Garden is doing an urban saguaro survey project that you can participate in by signing up via the Desert Botanic Garden website on iNaturalist if you're interested in helping Dr. Hernandez put together some Phoenix saguaro data. So if you have any questions about that, let me know. Big surprise, right, is that water is the main limiting resource for saguaro distributions. The other limiting factor on the distribution of the saguaro is frost. They're not very well frost adapted. The way that water works in the Sonoran Desert seems to really drive the distributions of saguaros. These are all pictures of various perspectives of Tumamoc Hill and the saguaros on Tumamoc Hill, where I'm currently working, by the way. So, bunch of adaptations that are in common with a lot of succulents and cacti: water storage in the stem, no persistent leaves, a special kind of photosynthesis that's called crassulation acid metabolism. It's an amazing adaptation of water-limited plants in particular, where they do all their gas exchange at night when it's cool. So they open up and breathe. They do all their breathing overnight, and then they all close up when the sun comes up. And the light reaction of photosynthesis happens during the day with the plant using carbon that it has stored overnight as malic acid. That's why it's called crassulation acid metabolism, because they store the carbon from the respiration overnight. So it's really a very cool adaptation. Saguaros, I don't know if you've ever noticed this about saguaros or other cacti for that matter. They have a thick, really waxy kind of cuticle on the epidermis, the skin of the plant, and that helps prevent loss of a lot of water. They can expand and contract like an accordion. When it rains, they get really fat, and then over long dry periods, they get really skinny, and they can grow 30 to 40% horizontally, expansion, which is really amazing that they have that physiology. They're often established under nurse plant species, or even as with rocks that help moderate temperature, keep a little bit of the frost away, from the rock re-radiating heat. The radial roots of saguaros are very extensive and close to the surface of the soil. Most of them have a really big taproot that goes straight down that anchors the plant, but they also have these radial roots that go all the way around. And one estimate that's been provided from a study about 40 years ago is that the radius of the root system is roughly equal to the height of the saguaro. So if a saguaro is 24 feet tall, 8 meters, which is fairly common for the older ones, the radius of the roots all the way around are about 24 feet. And that might be why urban saguaros are often stressed, because it's rare, I think, in a lot of urban situations to provide that kind of area for the root system. They're really slow growing, but they also grow very rapidly in response to available water, especially during the monsoons. On the left is a 12-meter extendable pole that we're using to measure the height of the main stems. Very old school. We're not using any fancy tech or anything. We just use this telescoping pole here. And you can see this saguaro's epidermis has got a bunch of browning on it. Could be sunburn. It's amazing to think, that these tough desert plants actually get sunburned, but that gives you a sense of the harshness, of the climate. There's some suggestion that this could also be frost damage. We don't really know. This is another view of my buddy Frank at my apartment building, just to show the bird holes. One of the ecosystem services that saguaros provide is as a home, like a condominium almost, for different species of birds. And I was just telling Luis here in the field, who's helping me out collecting data, that there's usually a succession of species that occupy these holes. It's really fascinating that it's like, it starts with the flicker or the woodpecker, and then usually it's the cactus wren that moves in after the woodpeckers leave. And then after the cactus wrens leave, the elf owls move in. And for some reason, after the elf owls live there, the birds tend to nobody occupies the nest anymore. So I don't know what the owls do. And then on the right here, it shows you just how weathered and kind of protective, kind of bark that the epidermis of a lot of saguaros form. And it doesn't seem to affect their health. It's not, it's not always a sign of ill health or anything. It's just a protective structure that they form near the base, especially. So here's an example of the way that saguaros tend to reproduce in their habitat. Although you will see saguaros very widely separated in habitat. Some of them are hundreds of yards from other ones and sometimes just growing completely in the open. But a lot of the time, and I think really more of the time, you see groups of saguaros that germinate and survive in these little microhabitats underneath the Palo Verde trees, either the foothill Palo Verde or the blue, depending, on the habitat, and other vegetation. And this little cohort of saguaros here was surveyed in 2012. They were all new in 2012, the last survey that was done here on Tumamoc. And so these were probably already about 10 years old at that time. So this is a little group of roughly 20-year-old saguaros, which is pretty amazing to think about. They don't always all survive. Once they get to a certain size, they start to compete with each other, and some of them make it and some don't. So it'll be interesting to see, 10 or 20 years from now, what this little cohort of young, relatively young saguaros looks like. And then one of the really important parts about saguaro ecology, put my hat on here because the sun's coming around. The sun is sneaking past the saguaro that I was hiding behind. But anyway, is a lot of the different kinds of associated vegetation that saguaros grow with. And I wanted to put this background in the presentation because it affects the growth rate to a large degree. Saguaros that grow in nurse situations are ones that are dependent to a large degree on covering vegetation, canopy. So they're underneath the shrubs. And that seems to be a really very favorable set of conditions. But the trade-off, and there's always trade-offs, right, is that they don't photosynthesize enough, or as much anyway, under there because of the shade. And as a result, when saguaros are young, they tend to grow very slowly. And even if they're in the broken sun of like the desert hackberry, Jatropha, and Celia farinosa, the brittle bush, even just in that broken sun, the photosynthetic rate goes pretty far down. So their growth isn't really very quick when they're in that nurse situation, but they gain the advantage of, moderated temperature, more water availability, and shade. On the left there is the whitethorn acacia, which is not in the genus Acacia anymore, but it's still the same plant. And on the right is the wolfberry. Yeah, wolfberry, Lycium berlandieri, which is very common here on Tumamoc. And these you find very commonly associated with the saguaros. And then, of course, the big player with associated vegetation is the foothills or blue, Palo Verde. And it really seems to be the primary nurse plant for seedlings. The whole life cycle has been pretty well studied. And there's a very strong association on Tumamoc, for example, between foothills, Palo Verde, and saguaros. And now in the preserve, I don't know the situation. I haven't actually done any field work in the preserve yet, but probably that'll be remedied, sometime soon, because I would love to get out there and check out the saguaro population that's up there. But I know here in the Tucson area, in the Sonoran Desert uplands, the association between the Palo Verde trees and the saguaros is very strong, and I'll show you an image of that soon. And I talked about the trade-offs already. So there's always trade-offs, there's always benefits. And another cool thing is that given enough time, the saguaros grow above the Palo Verde canopy, and that really affects their growth rate. And you need to factor that into an estimate of their age. So we'll talk about that later. So here's a picture from the mapping software that we're using to do the saguaro survey. On this image, each of the green dots is a saguaro that's been marked, the position's been marked using really high accuracy GPS technology. And the number is the permanent ID number of that saguaro. So like saguaro 413, saguaro 414, etc. And you can see really clearly, this is on the north plot, the very strong association between the occurrence of these saguaros and the Palo Verdes. And this is really high resolution aerial imagery where you can actually see the shadow of the saguaro right here. This, that's saguaro 414, and there's the shadow. You can see it's growing right on the edge of Palo Verde. There's almost, it's almost a 1-to-1 correspondence between the saguaro and the Palo Verde. So it's just this very strong association, and it really affects their growth rate, their age, their survival capability, etc. Another factor in saguaro ecology now is Buffelgrass, which you're all probably familiar with. You know that it rapidly colonizes. It probably outcompetes most native grass. We don't really know the interaction effects with saguaros, except for the effect of fire, which is very well known, which it's highly destructive. Buffelgrass fires are very hot. Saguaros are not fire adapted for the most part, but we don't know, like if fire is not part of the equation, exactly how does Buffelgrass affect saguaro ecology? So one of the things we're trying to figure out on Tumamoc is that. So, what are the impacts of Buffelgrass on recruitment, growth rate, population density, et cetera? That's one of the things we're studying. So there's Luis, who is one of the field techs there, getting the data on that saguaro right in front of him there in the Buffelgrass. And this is on the upper north plot on Tumamoc. And this particular area you can see is just a sea of Buffelgrass. And within that area, you also might notice that there isn't a whole lot of visible saguaro action going on. If there are saguaros in this grass, they're probably quite small. And then there's several older individuals in a different kind of vegetative regime just behind the Buffelgrass. So we're seeing a lot of that kind of fragmentation of habitat. And wherever there's open areas like that, the Buffelgrass just tends to go crazy. Now, whether they choke out the saguaros or slow their growth rate down, or if Buffelgrass serves a nurse function that actually helps saguaros germinate and survive, we have no idea. So it'll be interesting to find out. Okay, so that's a lot of background. You can tell I'm pretty interested in these plants. Now we get to the question, right? How old is that saguaro? So the main way that scientists have tried to get a handle on that question is by studying the age height curve for saguaros. And basically you just get a bunch of repeat data that helps you figure out the growth rate of saguaros, and you plot that all out and take a look at estimates of age based on height. It's a very simple two variable thing, right? You got age on one axis and height on the other, and you're just kind of trying to create an estimate based on that relationship between age and height. And one of the things that got people thinking about this is you look at a lot of saguaro landscapes, you might see a whole bunch of them that are pretty much the same height. They're all they're all looking pretty similar, and they have a similar number of arms. And so people started to realize about 100 years ago that saguaros seem to go through episodic recruitment, it's called. And that is where there are these 3 to 5 year periods of ideal conditions for saguaros to not only germinate but survive long enough to become established. And they form what's called a cohort. And all the saguaros in that cohort are approximately the same age. So that helped some, scientists kind of get a handle on the age of different cohorts of saguaros, especially when they were able to tie those cohorts to historical climate data. And the historical climate data, became more and more available throughout the 20th century. And that really was, there's a lot of tie-ins with that data. And this is the east slope, by the way, on Tumamoc Hill, and you can see quite a few are almost the same height, or look like you would estimate, well, they're probably the same age. And then you see there must have been a second cohort because there are these medium guys that don't have any arms yet, or this guy has one little arm coming out. There's another one of the medium ones over here, but they're mixed in with these much older individuals. And this is on the west slope, similar phenomenon on the west slope. It's even more pronounced over on the west at Tumamoc, where there are very few smaller saguaros. These are all significantly older. So thinking about that, people were looking at some patterns that seemed to provide the ideal conditions for recruitment. They started to tie that data to the age of some of these cohorts. So 3 or 4 years of soaking winter rain, mild winters, very important, no frost, no hard frost. And then the same year, really good monsoons also. So it's that Sonoran Desert biseasonal rain, summer, winter. And then you need establishment potential with the associated vegetation being healthy too. So areas where there was a lot of logging, extraction, right, of the Palo Verdes, or the mesquites, which they can also be very strongly associated with, that tended to impact these cohorts. And then people realized for several years after germination, no frost and no drought. So pretty picky for the Sonoran, right? And if you combine those, you get these sweet conditions, right, for the establishment of these cohorts, but they really only occur about every 100 years or so. And they may be less frequent now than they were. So that'll be, a part of what we're studying as well. This is just an example of a younger saguaro. I would say my estimate for this one would be about 20 years old, roughly. And you can see that it was using the Christmas cholla, Cylindropuntia leptocollis, as a bit of a nurse, right? A little protection, etc. And sometimes you see that. You see them with chollas, you'll see them with mesquites, you'll see them with Palo Verde. They like to associate with other plants that help them out. Growth rate. People started to figure out what affects the growth rate of survivals of saguaros and their survival. Two different things, right? So one thing they figured out really early was that the ideal conditions for recruitment of new saguaros are not the same as conditions for growth rate and survival. So they're two different niches that need to be fulfilled. Growth rate does depend on the biseasonal rain, but especially the monsoons. And what we know for sure is many individuals and populations of saguaros are capable of holding on for even decades through severe conditions. So persistence is very different from establishment. Now, growth rate really slows down during droughts. So you have to kind of factor that into your estimate of how old the saguaro is, right? Which I am going to get to, by the way. Hard frosts kill off a lot of saguaros, especially the older ones seem more vulnerable. Growth rate is really variable. So you like the saguaros in the preserve, for example, may have a very different growth rate from saguaros, let's say in up around Kingman, which is sort of the very edge of their range way up there. And then Maricopa County saguaros have been estimated to be about 60% of the growth rate of plants that get about an inch or two more rain per year. So that's how sensitive they are to those factors. So when you calculate age, if you're up in Maricopa County, you're really looking at older saguaros with a shorter height. So I'll talk about that in a second. Here's an example of several older saguaros, probably more like 70 or 75 years old. They're getting ready to put out arms. They're already flowering, and they're all taking advantage of this mesquite. So here we go. The generalized growth curve and the age-height relationship. So the growth rate varies by location. Many different populations, they show that the general curve is the same. And I'll show you that in a second. Growth rate is dependent on how big the saguaro is, oddly enough. The little ones don't grow very fast, and the bigger ones grow a lot quicker until they get to a certain size, and then they slow way down. So here's the growth rate versus height. These are dense, a little bit weird to read sometimes, but you get the idea that you have the height in centimeters along the x-axis, the horizontal, and you have the annual growth rate in centimeters on the y-axis. And you can see plants, roughly smaller, right, than 10 centimeters grow very slowly. Their annual growth rate is less than, sometimes significantly less than 5 centimeters a year, which is not much, right? But then you see as they get taller, they grow faster and faster until this sweet spot right around the peak of the curve there, where, and by the way, the top is, as it says, SNP East. That's the eastern unit of Saguaro National Park. And then the bottom is SNP West. And you can see the curve is very similar between the two habitats. The growth rates are very different, but the curve is the same, and that's the crucial part. And then after they hit that sweet spot somewhere in there, the growth rate goes way down of the main stem. But usually what's happening with those individuals is they're putting a lot of energy into growing arms and flowering. So at their peak growth rate, they're getting ready to produce a lot of other vegetative biomass of arms and flowers. So that's the curve. When you study any population of saguaros, they all fit that curve. The rate on the left is very different depending on environmental conditions, but the curve comes out the same over and over again. So I hope that comes through. And another illustration is this age-height pattern thing from Taylor Dresner, and she did these estimates of height versus age, and you can see again along the x-axis is the age in years, And along the y-axis is the height in centimeters, and it's a little easier sometimes to think in meters. So 800 centimeters is 8 meters, so roughly 24 feet tall. And you can see the wide variation, like under ideal conditions, you can get to about 24 feet tall after only 60 years. But under harsher conditions, it takes an extra century to get to that height. So that's how you kind of read this table. At 80 years, under harsh conditions, a saguaro is probably only about 3 meters tall. But after 80 years, under ideal conditions, a saguaro could be 10 meters tall. So that gives you an idea of the level of variation depending on habitat and environmental conditions. And then some more graphs. Up at the top is saguaro population density between 1950 and 2010 at 10 different sites. And then below is the annual growth rate. Notice how similar these, and this is across 10 different kinds of habitat. West Sonoran, Sonoran Desert upland, Tumamoc Hill is in here. And, the curve is the same. And then the age-height relationship at the bottom, which is derived basically from that curve, shows you similar patterns. If a saguaro is 10 meters tall, it's probably about 150 years old. And that's at the SILV site, which I think that's the Silver Bell Mountains. At the Tumamoc site, if it's 10 meters tall, it's probably about 120 years old. So that's how you read this. You just look for the intersections between the height and the age and kind of scope it out. And you'll notice that in the Western Sonoran, way over by Yuma and, really harsh, that to get to be 10 meters, you're significantly older. You're closer to almost 200 years old if you're 30 feet tall. So that shows you some of the variation. So how old is that saguaro? It depends. However, you can estimate based on knowledge of local conditions. So like I said, Maricopa County is estimated to be about 60% of the ideal growth rate. So I would say if you're looking at a saguaro that's about 24 feet tall, probably has about 4 arms, maybe 5 or 3 to 5 arms. In Maricopa County, I would say that an 8 meter or 24 foot tall, big old, saguaro in the wild, by the way, not in somebody's yard, is about 175 years old. Somewhere between 150 and 200 would be the range. On the other hand, if you were in ideal conditions, you're looking at a 24 foot tall saguaro with 3 arms, that's not 60% of the growth rate. It might only be about 90 or 100 years old. So you're looking at quite a range. There's a lot of error in some of these estimates. But depending, and like I said, the growth rate in Maricopa County is a little bit slower. It's a harsher environment for saguaros in many ways. So you can estimate a probable range of ages. So from germination to about half to 1 meter tall, they're very slow growers. After about a meter, they really take off. The first arms usually come out about 50 to 70 years. So if you're seeing a saguaro with 1 arm coming out, it's probably about 50 to 70 years old. And the main stem slows down as you see more arms come out. A large one, like I said, is about 150. The estimate is they germinated in 1890, which is pretty amazing to think about, right? They become more likely to die as they age. So a lot of the times, the press will report these huge old saguaros. They get blown over, they die. What a tragedy! But it's just more likely, actually. Like a lot of longer lived organisms, the more, the larger actually and older, the less likely the survivorship is from one year to the next. Okay, so on Tumamoc Hill, we're doing a bunch of different kinds of research, and I just wanted to tell you a little bit about what we're doing. We want to know in particular, is it stable, declining, or increasing? Because we have 114 years of data, so we'll be able to get a good picture. And we're going to refine the age estimates of a lot of the population. We really want to know what's going on with Buffelgrass and saguaro growth rate. And we're going to try to incorporate the data from Tumamoc into some other data sets that are available that we have access to. So the first survey here on Tumamoc was in 1908. A lot of the plants that we're measuring now, in fact, the one I'm sitting right next to was part of the 1908 survey. So that's really cool. 114 years, you're measuring this cactus, it's really amazing. Ray Turner and Rod Hastings set the plots up 58 years ago, and the surveys have been done about every 10 years. And there's about 4,000 saguaros in our data set, so it's a lot. And this is just a view of the lower north plot on Tumamoc looking toward Tucson. And there's another view with downtown Tucson in the distance there. This is from the, it's from the north plot again. There's a picture of Tumamoc Hill looking south. You can see all the Buffelgrass up on there. What we've been finding too is that there's a lot of natural or native grass around. So it's interesting to see the interaction too between the Buffelgrass and the native grass. And my other assistant, Ava, is here on the right, and she's looking at a group of 3 saguaros that were about 1.5 meters tall in 1908. It's very cool to be out there. You look back through the data, you're like, wow, these guys have been surveyed since 1908, and they've been surveyed, 5 times since the plots were set up since 1964, and they're still there. And these were all estimated to have germinated the same year. And the estimate is that these are approximately 175 years old. So that even in 1908, they were already, like 60 years old at that time, which is, it's pretty humbling to be out there getting data on these kinds of organisms. And there's Luis. He's working with that 12-meter pole, measuring a 9.7 meter tall saguaro, so, more than 30 feet tall. And in 1908, it was 1.2 meters. So, and that one estimated to have germinated in 1888. There's a look at our plots from way up in the air, and every single dot represents a saguaro, which is a little bit daunting. But we're over here on the west plot right now. In fact, I'm sitting right here. That's the actual, or wait a minute, I'm sitting right here. That's the actual saguaro that I'm sitting by. And we've surveyed a huge part of the west already in the north, and we have to do the south and the east still. We're estimated to be done by the end of January, I hope, maybe by the end of February. I just want to acknowledge University of Arizona, the Desert Lab at Tumamoc, the National Park Service, which has provided a lot of funding for all this saguaro research. And that's basically my presentation. Let me look in the chat here.
Peter, thank you so much. Bravo. This was awesome.
Yeah.
I have to say that, when you're talking about growth spurts, I couldn't help but think of, teenagers, like kids just kind of grow, and then all of a sudden teenagers shoot up and get to be the same. So Tumamoc is obviously one of the oldest surveys. What is the oldest survey kind of in the area where we are over at McDowell-Sonoran Preserve? What's the earliest survey there? Do you know?
I don't know. That's a great question. The vast majority of the saguaro research that's been done has been done in the Tucson area.
Okay.
But I can look into that. I'll get back to you.
Yeah, I was just curious, but when you talk about that, you're looking at a cactus that germinated in 1888. Was first surveyed in 1908.
Yeah.
It's really fascinating. It's fantastic.
When you survey something that's like 1 meter tall, and it's already, or 3 feet tall, it's already 35 years old. You know what I mean?
Yeah, for sure.
So, yeah.
Very cool. You can take down your presentation if you want. We can help you out with the questions here.
Yeah, let me do that. I will stop share. Okay.
Okay, there you go. So we're going to let my assistant help you out by reading the questions here.
Okay.
Hi, Peter, we have about 6 questions, a lot of them that relating to the arms of the cacti.
Oh, yeah.
So for Carrie wanted to know, it seems almost purposeful that the saguaros don't grow their arms for such a long time. Is there any reason or value to the plant for growing arms when they do?
That's a great question. I would say one of the physiological or like trait, characteristic, adaptation kind of thing, about saguaros that has really not been very well studied is the whole arm thing. And it's funny that it really hasn't been a focus of a lot of study because it's so iconic, that the shape of the plant, when you think of saguaro, you don't think of a little one, you don't think of a single stem, you're thinking about, the arms. So it's, scientists haven't really taken that apart much, but so let me tell you what's not known, which is always fun. So if anybody wants to get their PhD in this, you could study saguaro arms. And take it from me, you get a PhD at any age, right? But anyway, so what's not known is why the arms come out where they do. Really simple question. And you see some really crazy saguaros that have arms near the top, and then they have arms really low down. Sometimes, the most common thing is for the arms to come out sort of at the middle of the stem, right? But that's not always the case. They have a mind of their own. And some of the more whimsical shapes you see and everything, is this crazy arm behavior. So we don't know why they come out where they do. We don't know what the trigger is at the growth point, for the saguaro to say, hey, I'm going to create an arm there. There is a correlation between wounds, especially decapitation, and one of the weird things that happens to saguaros is they get completely broken off, usually about halfway through the stem or maybe near the top. And it's usually wind, really strong microburst comes through and just snaps the saguaro in two. But you'll often notice that around one of those decapitations, a bunch of arms come out and it just keeps going. It's like, you can't stop me. They're very persistent. But we don't know exactly what that trigger is, and we don't really know the relationship between the saguaro producing the arms and the impact on the population density and reproduction. You guess that arms serve a very important purpose of increasing the number of flowers because, the main stem can flower all around the top. You see that most years. And then the arms flower. Each arm has roughly as many flowers as the main stem has. So one of the real strong advantages of creating those arms is that you increase the number of flowers per individual cactus. And then I think another advantage is probably that the arms increase the photosynthetic rate of the plant, creating more energy, more food to, fuel the plant. But there's definite trade-off, because anytime you're investing that much energy to basically grow like a whole other plant, on yourself, it takes a tremendous amount of energy to do that as well. So it's it'd be a really fascinating area to study in greater depth. We're taking a photograph of every saguaro as we survey, and a undergraduate student at U of A is going to analyze those photos for number of arms and how estimates of how long they are. And we're hoping to break that data down to understand better what the population trade-offs are, of creating those arms. But I hope that helps. One of the things that saguaros don't do is they don't drop their arms and have them take root. There's a lot of other cacti that do reproduce vegetatively by having their shoots fall off and root in the ground, but saguaros don't do that. They don't reproduce that way. So, yeah.
So most of them are about the arms, and I think you've covered a lot of the answers. But someone's asked about what determines the direction that the arms might grow, and
Right.
you've said that there's no rhyme or reason, if I understood you correctly.
Well, there's a typical growth pattern, which is the arms come out and go up.
Right.
And for plants, that's usually a photo response, to light. So I would assume, although I'm kind of talking out of my hat here, which I am wearing, because nobody really knows. But you do see these arms that grow in these weird shapes, that they go down. And that might just be physiological. There might be a really heavy rain one time and they just get too heavy, and they kind of bend. But yeah, it's a really good question. The arm behavior is a fascinating aspect of the plants that has not been very carefully studied. So
you did mention in one of the pictures that the saguaro was getting ready to get arms.
right.
Is there a specific way that we know? Janine wants to know. Is there a specific way that we know that there's about the arms to come out, that you're looking at the cactus, or?
Yeah, it's usually, and this is just anecdotal from different people who've studied saguaros for a long time. There's a guy down here in Tucson who's an amateur saguaro fanatic who's been recording saguaro flowering data for the past 50 years or so, since he was like 20. His name is Bill Peachy, and he's amazing saguaro wisdom guy. And he says that the arms are about to come out after the main stem has flowered for about 3 to 5 years or so. So if you see the main, so it's just a single stem, and it's usually about 1.5 to 2 meters, or about 6 feet tall, roughly human height, right? Around then is pretty much when they're going to start putting, creating arms, 1 arm, 2 arms. But, there's no guarantees. Some saguaros that we've surveyed, for example, are like 25 feet tall and still don't have any arms. It's just this big straight stem, and other little ones, start to put out these arms at only like 3 feet tall. So it's an interesting area for sure.
Yeah, that was one of the questions. Why do some saguaros not grow arms? Saw what you just mentioned, but
We don't know.
we don't know.
Yeah. Yeah, it's
is there a second generation growth of arms, and when does it start?
Yeah, there is a second generation of arm growth. You see oftentimes saguaros that have arms that are roughly the same length, and they'll be in a ring kind of around the saguaro, and they're usually, let's say, about 1/3 of the height of the main stem, and they're all pretty much the same length. And then if you look up, you'll see the saguaro starting to put some new arms out closer to the top of the stem. And that's a very common pattern. I think there's some kind of physiological cue, that's probably hormones. The way that plant hormones work to trigger new plant growth is not really been connected to saguaro physiology, but that would be a really fascinating study also.
Yeah. Is there a maximum like height and age of the saguaro that they reach and then die?
Yeah, there's with the exception of some outliers, right? Some crazy tall saguaro years ago that was considered to be the tallest saguaro, like of all the saguaros. And it was it was like 56 feet tall or something like that, so that was like almost 20 meters tall. But that one died about 25 years ago. It was in Sabino Canyon here. I think it was in Sabino Canyon, in the Catalina Mountains here in Tucson. So we purchased a 12-meter telescoping pole because for the most part, The maximum height of most, main stem saguaros is about 12 meters, 24 feet. So we were pretty safe buying a pole that was only 12 meters. There are 10 saguaros on Tumamoc Hill that are taller than 12 meters. And we bought a laser rangefinder to estimate their height. So we're actually using trigonometry in this laser, which is pretty weird, to estimate how tall they are. And one of them is 14.5 meters tall, which is, remarkable. That's almost 43 feet tall. But, once they get up above about 12 meters, you start to see a lot more signs of stress in the plant, a lot more bark on the lower part of the stem, a lot more bird holes and epidermal damage, browning, and just rough, they get to be in pretty rough shape. And as I said, the survivorship curve for saguaros is very similar to, for us, which, I'm 61 now and I've started thinking about it more than I did like 10 years ago, right? But with each, increment of time that goes by, we become a different proposition for the insurance companies, So, and that's true for saguaros too. The older they get, the more vulnerable they are to various, stressors and issues with their environment.
So one non-armed question from Robin was, when saguaros are transplanted, notice that the root system is not there.
Yeah.
How does that impact the actual transplant and the growth?
That's a great question. There's a few tricks to increasing the chances that a saguaro will survive a transplant. And a lot of the rescued saguaros, man, their roots are just gone because they're dug up, pretty quickly. Right. But one thing you want to do is think about how tall the saguaro is. So if the saguaro is about 6 feet tall, see if you can prepare the soil around the transplant to a radius of about 6 feet. Break it up, make it looser, make sure water can penetrate down in there. And then when you plant the saguaro, stabilize it. You'll notice a lot of saguaros after transplanting are propped up with 2x4s. And the other trick is you really want to face them the same way. So you see, if you go to a nursery like Arizona Cactus Sales or, a place that sells saguaros, they have a mark on the north side usually of the saguaro. Right. And when you plant that out, you want to make sure you face that mark to the north, because otherwise the north side of the saguaro can get terribly sunburned and it actually can kill the plant. So if you do all those things, the plant will very quickly, like within 2 or 3 years, put out those radial roots. Especially if you break the soil up and if you have the space, if you want to grow.
Oops. It froze up.
I didn't do anything.
Yeah, no. Peter, you're froze up. At least you are for us. I don't know if that's true of all our participants today. It's about 1 o'clock, so I guess we'll say goodbye. Certainly this wasn't purposeful, but thank you so much. It was really fascinating and a lot of fun. And I think it even made it more fun to see you out there in the field. So our appreciation for your time and expertise. And when you get up our way, come and say hey. Hope to see you soon. Bye, everybody.